Hi everybody, I am back and today we will talk about molecular geometry or molecular shape, what is the same. In order to define the molecular geometry, we will use BLTS method, like BLT sandwich method. Just for information, here I put the picture from Google of BLT sandwich. Let's have a look at this picture where we have two molecules. So the first one is tetrahedral, the second one is trigonal pyramidal. How to identify, to determine which shape any kind of molecule has? So if we look at the first molecule, we see we have one central atom and four atoms around it, four lateral atoms around it. If we look at the second molecule, we see that there is one central atom and three lateral atoms around it. Let's have a look at this table. So what we have? We have such a table where we write, pay attention on the hints, BLTS. We write the first letters of BLT sandwich, BLTS. And let's see, there can be two bonding pairs. If we have two bonding pairs and one lone pair, or two bonding pairs and two lone pairs, it will be B. B represents bent, so the shape will be bent. If we have two bonding pairs and three lone pairs, it will be L, what means linear. In the case that we have three bonding pairs, let's see, we can have one lone pair and two lone pairs. For both of them, if we have three bonding pairs, it will be T, letter will be for T, but it can be trigonal pyramidal or T-shape. If we have only one lone pair, it will be trigonal pyramidal. If we have two lone pairs, it will be T-shape. In order not to confuse the order, look, trigonal pyramidal, P, and the second one, T-shape, is S. P in the alphabet comes before S. So 3-1 will be trigonal pyramidal, 3-2 will be T-shape. Let's now continue. If we have four bonding pairs or five bonding pairs, it will be for S. So four bonding pairs and one lone pair will be seesaw. If we have four bonding pairs and two lone pairs, it will be square planar. Then five bonding pairs and one lone pair will be square pyramidal. This is just three of them that you should remember their orders. That's it. If you remember this table, it will be easy for you to memorize, to remember the shape of the molecules. But it happens that sometimes a molecule does not have any lone pair. So number of lone pairs is 0. In this case, we will use another table. Let's see. Number of lone pairs is always 0. If it has two bonding pairs, imagine the carbon dioxide molecule. C, the central atom, and two oxygens as lateral atoms. So in this case, it will be just linear. Then, if we have three bonding pairs, look, we know 3 means 3. So remember, trigonal planar. Four bonding pairs. 4 is tetra, so tetrahedral. If we have five bonding pairs, look, it will be a bit different. We will just represent 5 as 3 plus 2. So trigonal, B pyramidal. 3, 3, B is 2. 3 and 2 are 5. The last one, 6 bonding pairs, it seems a bit tricky. Look, octahedral. We know octa is 8. We just simply multiply 8 by 2, we get 16. The last one, 6, and 6 bonding pairs. Just like it. So we can use this trick to memorize the shape of molecules. And now let's return to these two molecules. We see that the first one, it has one central atom and four atoms which are bonded to it. So 4 bonding pairs. If we look at our table, it will be tetrahedral. The second one is trigonal pyramidal. Okay, we will discuss more detailed why trigonal pyramidal, why not trigonal planar. You see the shape is trigonal pyramidal. Let's see the difference between the first molecule and the second molecule to understand it better. What is the difference? This one. This atom. In the first molecule, look, they both are the same. Just in the first case, we have 4 atoms. In the second one, we have 3 atoms. The one is missing. Indeed, for the second case, instead of 1 atom, there is a lone pair. Just we do not see it. Let's take this atom, the first one, and let's consider that the fourth atom indeed is not an atom, but it's a lone pair. And let's change the color, it will be orange. So now we have one central atom, 3 atoms which are bonded to it, so 3 bonding pairs, and 1 lone pair. So when we are talking about a molecular shape or a molecular geometry, we do not consider the lone pair. Like, we consider it for the shape, but we do not see it. It will look like this, the molecule. If we add a lone pair, it will be like this. So, look at these 2 pictures. We see that in the same molecule, just in the first case, we see the lone pair. In the second one, we don't see it. But it's the same thing. And let's go to the table. We have 3 bonding pairs for this one, yes? We have 3 bonding pairs, and we have 1 lone pair. So according to our BLTS table, it will be trigonal pyramidal. That's why, even if we don't see the lone pair, but it anyway affects the shape of a molecule. So the shape of a molecule will be trigonal pyramidal. If we consider electronic geometry, when we consider electronic geometry, it differs from molecular geometry. So molecular geometry is trigonal pyramidal, but electronic geometry will be tetrahedral. It will be tetrahedral because we will consider all 4 electron pairs, all of them. So when we are talking about molecular geometry, we consider only the atoms bonded to it, and we don't see the electron. In the case if we want to talk about electronic geometry, we consider also lone pair, so it will be tetrahedral. Electron geometry will be tetrahedral, while molecular geometry will be trigonal pyramidal. And as an example, let's take ammonia molecule. Let's draw a Lewis structure. It will be like this. So we see from the Lewis structure, we have 1 central atom, which is nitrogen, 3 surrounding atoms, so it means we have 3 bonding pairs, and 1 lone pair on nitrogen on our central atom. So let's remember our table, BLTS table. 3 bonding pairs and 1 lone pair. We see from the table it is trigonal pyramidal. So ammonia molecule will have trigonal pyramidal shape. Let's consider green ones are hydrogen, the black one is nitrogen. And the lone pair, now I will make it orange. And we add 1 orange, which means this is a lone pair, which is on nitrogen. So if we consider electronic geometry, not molecular, but electronic geometry, it will be like 4 and 0. We consider all the pairs, not only bonding pairs, but all the pairs, and it will be tetrahedral. If we would like to consider molecular geometry, in this case, it will be trigonal pyramidal. When we are talking about molecular geometry, what do we say? A central atom is surrounded by 3 lateral atoms and 1 lone pair. So we have 3 bonding pairs and 1 lone pair. The shape is trigonal pyramidal. If we consider electron geometry, we consider all of the pairs like atoms. We imagine that this lone pair is also an atom, so we consider 4 electron pairs. So we don't care if it's bonding pair or it's lone pair. We consider them all just like electron pairs. So in this case it will be tetrahedral. That's why do not confuse these two terms, molecular geometry and electron geometry. Molecular geometry is a molecular shape. Electron geometry is a shape that a molecule would have if instead of a lone pair we would have one bonding pair. That's it. So that's all for today. Hope it was clear, and see you in our next videos. Bye.